Everyone, today we will discuss the classification of alcohols and phenols. Okay, so first of all we have to classify here what are the different types of alcohols on the basis of their structures. Okay, so on the basis of, first of all, let me tell you, on the basis of number of OH groups, alcohol and phenols alcohols and phenols alcohols and phenols can be classified into different types. Okay, into different types. So here we have to classify alcohols and phenols on the basis of number of OH groups. It's very simple to all of you. If one OH group is actually present, if the alcohol or a phenol contains only one OH group, then that kinds of alcohol or phenol is called as monohydric alcohol. Okay, it is clear to all of you. When the alcohol contains one OH group, then it is called as monohydric alcohol. Example, let us take an example. Here example is CH3OH. This is called as methanol. As you clearly see here, this compound contains one OH group. Like this, if two OH group is present, then it is called as dihydric alcohol. Clear? Example, CH2OH and another CH2OH. So this is an example of dihydric alcohol. Let us write its name. So in our next class we can easily read our nomenclature, or I can explain you the nomenclature of the alcohols and phenols. Okay, so in this class we will only study our classification of alcohols and phenols. Okay, so this is our methanol. Okay, and this is called as what? 1,2. So 1,2 means ethane 1,2-diol. This is our ethane 1,2-diol. This is an example of dihydric alcohol. Why? Because it contains how many OH groups? 2 OH groups. If 3 OH groups are present, then it is called as trihydric alcohol. So more than 3, we can say that it is an example of polyhydric alcohols. I hope it is clear to all of you. Okay, so let us take an example of trihydric alcohol, CH2OH, then CHOH, then another CH2OH. So this is our example of what? This is our example of trihydric alcohol. Like this, phenol can be written into different types. So if any phenol contains one OH, that is called as monohydric phenol. This is called as monohydric. Here it contains only one. This formula is actually called as phenol. Okay, but it is monohydric. If it contains how many? 2 OH groups. If it contains 2 OH group at any position, then it is called as what? Dihydric alcohol. If it contains 3 OH group, then we can call the structure into trihydric. Okay, you can take OH group at any position, but this is, if it contains 3 OH group, then it is called as what? Trihydric alcohol. I hope it is clear to all of you. Okay, so now again we have to classify the monohydric alcohols on the basis of hybridization of carbon atoms. Okay, so on the basis of hybridization, so what actually is hybridization? So we have to clearly understand what actually hybridization, and we all know that hybridization means sp2 sp3. So here first of heading is our compounds containing CsP3OH bond. That means what? That means the OH group is attached to that carbon atom which most undergoes sp3 hybridization. Okay, let us take an example first, then we will clearly understand what actually the heading tells us or tell us. Okay, so let us take an example of primary alcohol. Okay, so if I will take here a primary alcohol, okay, from sp3 means what? Sp3 means what? Let us take an example. Okay, primary alcohol. Primary alcohol, what is primary alcohol? If the OH group is attached to one carbon atom and that carbon atom is attached to another carbon atom, then this kind of alcohol is called as primary alcohol. As you clearly see here, OH group is attached to one carbon atom and this carbon atom perform only 4 sigma bonds or form only 4 sigma bonds. If you calculate its hybridization is equal to 4 sigma plus 0 lone pair. That means only 4 sigma bonds are actually present. That means it has 4 sigma bond. So 4 hybridized or 4 orbital must mixed with each other and sp3 hybridization must take place in this. So this carbon performs sp3 hybridization. That means we can say that this carbon is sp3 hybridized. So sp3 carbon is attached to OH group. So this is an example of primary alcohol. Why it is called as primary alcohol? Because here the functional group OH is attached to one carbon atom which also attached to another carbon atom. So these two carbon atoms are called as 1 degree. Why? When carbon atom is attached to one carbon atom, then that carbon atom is called as 1 degree carbon atom. Okay, then secondary alcohol. What is secondary alcohol? Secondary alcohol means when the functional group is directly attached to carbon and that carbon is again attached to two carbon atom, then that compound is called as secondary alcohol. Here secondary alcohol, OH is our what? OH is our functional group. So when functional group is directly attached to one carbon atom, but this carbon atom is directly attached to two carbon atoms. That's why this kind of alcohol is called as secondary alcohol. If you calculate its hybridization, how many sigma bonds? This is our H. So 1, 2, 3, 4. 4 sigma bonds. That means it also forms what? sp3 hybridization. Now come to tertiary hybridization. Tertiary alcohol. What is tertiary alcohol? So tertiary alcohol means what? Tertiary alcohol means our carbon atom connects to that carbon atom which connects to one OH group and that carbon atom connects to 3 carbon atom again. Then that carbon atom is called as tertiary carbon atom. So this is called as tertiary alcohol. This is called as our tertiary alcohol. Okay. So tertiary alcohol also this carbon atom form 4 sigma bond 1, 2, 3, 4. That means it has 4 sigma bond. That means it also performs sp3 hybridization. So we can say that this is here this carbon is sp3 hybridized and sp3 hybridized carbon atom here are attached to directly OH groups. Okay, so I hope everyone clearly understand the according to carbon sp3 OH bond we can clearly classify into 3 types. What? First one primary, then secondary, then tertiary. Then our allylic alcohols. What is allylic alcohols? So allylic alcohol means what? Okay, so allylic alcohols. So allylic alcohol means what? Allylic alcohol means when OH group is directly attached to any carbon atom like this and that carbon atom is directly attached to carbon-carbon double bond, then that compound is called as allylic alcohol. This is an example of allylic alcohol. Okay, so if you determine the hybridization of the carbon which attached to the OH group, this carbon also perform 4 sigma bond. That means it has or it must perform sp3 hybridization. So we can say that allylic alcohol can undergoes on sp3 OH bond group. Okay. Like this secondary alcohol, we can classify secondary alcohol as CH2CH, then C H, then OH, then our C triple bond C. This is our secondary. How can we say that it is a secondary allylic alcohol? Because we all know that this carbon atom is directly attached to OH group, and this carbon atom is directly attached to two carbon atom. So we all know that if any carbon atom is directly attached to one functional group and same carbon atom is directly attached to two carbon atom, then that is called as secondary carbon atom. So it is called as secondary allylic alcohol. It is called as secondary allylic alcohol. Okay, it is clear to all of you. If that carbon atom is again attached to 3 carbon, is again attached to 3 carbon atom, so we can again say that this carbon is our tertiary. This carbon is our tertiary allylic alcohol. This is our 3 degree or tertiary allylic alcohol. I hope it is clear to all of you. So we so in this class we can clearly classify all the alcohols which are connected to OH group, and the carbon atoms are here are sp3 hybridized. Okay, now come to benzylic alcohol. What is benzylic alcohol? So we if I write here benzylic alcohol means what? Benzylic alcohol means a benzene group, that is, this is the structure of benzene, and a benzene group which is most attached with CH2, and this CH2 directly attached with OH. This is our benzylic alcohol. This is primary alcohol. What? This is primary alcohol. Why primary? Because we all know that this carbon is directly attached to only one carbon atom. That's why it is called as primary benzylic alcohol. If I talk about secondary benzylic alcohol, that means the carbon atom which directly attached to one OH group and again attached to an benzyl group or phenyl group which most attached to another carbon atom also, then that carbon is called as secondary carbon, and this is called as our secondary benzylic alcohol. If again in this structure, if I modify this structure and that single carbon atom is directly attached to any phenyl group, and total three carbon atoms are attached to a single carbon atom, and that single carbon atom is directly attached to one OH group, then that is called as what? Tertiary benzylic alcohol. So I hope it is clear to all of you. So here we can easily classify, or we classified all the alcohols and phenols in which OH group is directly attached to sp3 hybridized carbon atom. Clear to all of you? Okay. Now we will clearly classify the carbon sp2. So our heading is our compounds containing carbon sp2 OH bond. Okay, compounds containing carbon sp2 OH bonds. Clear? Okay, so what are its examples? We have already covered in our previous class, mainly in a haloalkane and a haloarine chapter. So here first one is vinylic alcohol. Okay, first group which is normally called as vinylic alcohol. What is vinylic alcohol? This is our vinylic alcohol. Let us clearly understand what actually is vinylic alcohol. Okay, if the OH group, this functional group is OH, if the OH group is directly attached to CH and this CH is directly attached to CH2 with double bond, then this kind of group is called as vinyl. and this is our alcohol. This is called as vinylic alcohol. Okay, so if you calculate the hybridization of this carbon atom which directly attached to OH group, how many sigma bonds? 3 sigma and 1 pi. So if so now the hybridization is what? Hybridization 3 sigma plus 0 lone pair. That means how many sigma bonds? 3 sigma bonds. 3 sigma bond means what? 3 orbital most mixed with each other, and it performs what? sp2 hybridations. That means this carbon atom perform sp2 hybridization. Let us check it clearly again to clearly understand what actually is vinylic alcohol. Let us take another example. Okay, or I can repeat this example. CH2 double bond C single bond H, then OH. Okay, so here is our functional group OH. Simple. This carbon is directly attached to OH. That means this is our main carbon atom. We have to calculate its hybridization. So this carbon atom is directly attached to OH by sigma bond. Then this is another sigma bond. There is another sigma bond and with a pi bond. So how many sigma bonds? How many sigma bond? 3 sigma bond. How many lone pair? 0 lone pair. So 3 sigma means what is the hybridization? sp2 hybridization. Why? Because 3 means 3 orbital must combine with each other. That means this is our what? Vinylic alcohol. I hope it is clear to all of you. Then come to phenol. Okay, phenol means, so phenol, second one is phenol. So if you draw the structure of phenol, this is like this. This is our structure of phenol. Okay, this is our structure of phenol. If I draw a more simple structure, that means carbon is directly attached to OH with sigma bonds like this. Okay, like this. And how many sigma bonds? Different kinds of sigma bonds. Sorry, these are pi bonds. These are pi bonds and these are sigma bonds. Okay, so now if you satisfy the valency of carbon atom, tetravalent character of carbon atom, so carbon must satisfy its valency with tetravalent nature. So if you focus on the functional group, that is OH, which is directly attached to carbon, and here carbon atom performs how many sigma bonds? 3 sigma bonds. That means it must perform sp2 hybridization. That means because it has 3 sigma bonds, if 3 sigma bond, then it must perform what? sp2 hybridization. So we can clearly say that this carbon atom is sp2 hybridized. Okay, I hope it is clear all of you, to all of you. Now come to ethers. So how can we easily classify ethers? So first of all, ethers introduction, you all know that, but let me take a simple examples of ether. So how can we easily get our ether? Okay, first let us take 2 example of ether. Okay, so if I take CH3O, let us take a methane molecule. Okay, methane, this is our methane. Okay, by just replacing one hydrogen atom and add OCH3. Okay, add OCH3. This is called as, this compound is called as methane. By replacing one hydrogen atom and adding OCH3, we will get here what? We will get here CH3OCH3. This is our ether. This is called as what? This is called as methoxymethane. This is called as methoxymethane. Clear? This is an example of ether. If in this methane, from this methane, if I replace one hydrogen atom, what will happen? CH3, that means methyl group is obtained, and add OC2H5. What will happen? We will get here CH3O C2H5. This is also an ether, but the problem is its name is what? Its name is ethoxymethane. Okay, so the different kinds of actually ethers were obtained in this structure. Okay, we have in this different kinds there are total 2 types of ethers are actually present. If you clearly understand here, on the both sides of oxygen, 2 methyl group is present. That means same alkyl groups. Okay, same alkyl groups. So this is our classification. If same alkyl groups are present, among sorry uh, along the side of oxygen, then it is called as simple ether. Then it is called as simple ether. If different these are different, this is methyl, this is methyl, this is ethyl. If different alkyl groups are present, then it is called as what? Mixed ether. It is called as mixed ether. Clear to all of you? This is simple ether, these are mixed ether. Very simple. Yes or no? Forget the name, but you have to clearly understand what is mixed ether, what is simple ether. Okay, so simple ether means what? Let me write the definition for all of you. What is simple ether? Simple ether means what? Simple ether means if two alkyl groups, if two alkyl groups are same on both side of oxygen, on both side of ether, on both side of ether, then it is called as, then it is called as simple ether, then it is called as simple ether. Example is CH3O CH3. This is an example of simple ether. C2H5O C2H5. Okay, C3H7O C3H7. Okay, after this class we will cover our nomenclature part. Okay, so forget the nomenclature. First of all, let us understand what is simple ether. So this is our simple ether: methoxymethane, ethoxyethane, then propoxypropane. Okay, so like this, if you take our mixed ether, what is mixed ether? Okay, mixed ether means what? Mixed ether means if two alkyl groups are different, if two alkyl groups are different on both sides, on both sides of ether, then it is called as, then it is called as mixed ether, then it is called as mixed ether. I hope it is clear to all of you. So let us take some example also. If I take CH3O C2H5, you all clear here, CH3 is methyl, CH3 is methyl, C2H5 is ethyl. That means it is an example of what? That means it is an example of mixed ether. Like this CH3O C3H7, this is also an example of what? Mixed ether. So I hope it is clear to all of you. So we just completed our what? Classification of alcohol, phenol and ether. Thank you everyone.